All right, this is the 2016 series questions. So they had us have a Taylor polynomial, and we're talking about convergence. They told us that f of 1 is equal to 1, f prime of 1 is equal to 1/2, and then they gave us a formula for calculating the derivative at x equals 1. So part A, they want us to find the first four terms and the general term. So they've told us f of 1 is equal to 1, f prime of 1 is equal to 2. So the next thing I'm going to do is find the second derivative at 1, which means I'm going to plug in n equals 2 over here in this formula. So over there, if n is equal to 2, it's going to be positive 2 minus 1 factorial, which is going to be 1 over 2 to the first power. So then I'm going to find the third term, which is going to be negative 3 minus 1, which is 2 factorial, all over 2 cubed. So my Taylor polynomial will look like, you'll have your f of 1, which is your constant, f prime at 1, x minus 1, and then your second derivative, your second power, your second factorial, then your third derivative, your third power, your third factorial. So let's see, our P3 is then going to be 1 plus 1/2. We just calculated the first derivative was 1/2, so I'm going to have plus 1/2 times 2 factorial, x minus 1 squared. And then we have the third derivative, which is minus 2 factorial over 2 cubed. And then here you're going to have x minus 1 cubed over 3 factorial. And then the general term everybody struggles with, but it's actually the easiest part. This is your nth derivative. So you're going to add your nth derivative, and then you're going to multiply that by the nth power and the nth factorial. Okay, and again, I like to look for nice consistencies. Constant, first power, second power, third power, fourth power. So here I've got 2 factorial, 3 factorial, 3, n minus 1 factorial, n factorial, n, 1 factorial, 2 factorial, 2. And one thing I noticed is that right here, I've got 2 factorial on the top and 3 factorial on the bottom. And here I've got n minus 1 factorial on the top and n factorial on the bottom. So we can actually cancel those and make it slightly easier, because I can cancel this, and this will now be 3. And of course, the same thing here. This is just n. Now, they told us that our general term, or our radius of convergence, is 2, and they want us to find the interval of convergence. So remember, right here is our gen term. This is what we just found. It was negative 1 to the n, x minus 1 to the n, 2 to the n, times n. We know our radius is equal to 2. This is centered at 1, so I'm going to go 2 each direction, so 3 and negative 1, and those are the ones we're going to have to check. And we plug it in there, so it'll be negative 1 to the n, negative 2 to the n. Notice that we're not alternating. It will not alternate, so this is p equals 1, and it is a harmonic, and it doesn't alternate, so it diverges. When we check the other side, 3 minus 1 is 2 to the n. Notice those guys cancel. So here this is p to the 1, our p value being 1, and it alternates, so it is going to converge because it's an alternating p series. And this will mean that our interval of convergence will not include negative 1 and go all the way up to 3 and including 3. So the next part asked us to find the first 3 non-zero terms. Use that to approximate f of 1.2. So the first 3 non-zero terms would be 1, 2, 3. So this is what I'm going to plug into. So f of 1.2 is approximately equal to 1 plus 1/2, and then you're going to do 1.2 minus 1, so 0.2, 1 over 2 factorial, and then 0.2 squared. And it shouldn't be a surprise that the next thing they're going to do is ask you for the error in the approximation. So D, remember for an alternating series, a convergent alternating series, the error is less than the first omitted term. So since we used a degree 2 Taylor polynomial, so degree 3 is going to talk about the error. And then for a convergent alternating series, the error is less than the first omitted term. If you look right here, here is our third term. Our error in absolute value is going to be less than, remember we plugged in 1.2 for x, so 0.2 to the third power, 3 cubed times 3. And they want us to show that this had at least 3 decimal places of accuracy, which I think you guys would agree. So this would be 27 on the bottom, actually 81 on the bottom, just from the 3's. And if you think of 0.2 as 1/5, so you have a 1 up here and then 5 cubed. And that's definitely going to be 3 decimal places of accuracy. So again, how was this scored? The first part A is worth 4 points. 1 for the first 2 terms being correct, 1 for the third term being correct, 1 for the fourth term being correct, and 1 for the general term being correct. B, 2 points. 1 to know what to check, and 1 for getting them correct. F of 1.2, just 1 point. And then here is what the error looks like and the analysis of it.